Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0135 indicates an issue with the air-fuel AF sensor, specifically a malfunction in the heater circuit associated with sensor 1. This sensor is crucial for monitoring the air-fuel mixture to optimize combustion and reduce emissions. In the Honda HRV, the AF sensor is typically located upstream of the catalytic converter in the exhaust system. Malfunctioning of this sensor can lead to decreased engine performance and increased emissions. It is important to address this issue promptly to avoid further complications and ensure smooth vehicle operation. This guide will help you diagnose and troubleshoot the specific malfunctions related to DTC P0135 in the Honda HRV models from 2016 to 2022. The AF sensor, sensor 1, performs a vital role in managing the air-fuel mixture for optimal engine performance and emissions control. It is located in the exhaust system upstream of the catalytic converter. By measuring the oxygen content in the exhaust gases, the AF sensor helps the engine control module, ECM, adjust the fuel injection and ignition timing, ensuring efficient combustion. A malfunction in the sensor's heater circuit can disrupt these readings, leading to inconsistent engine operation and increased emissions. The heating element within the sensor is essential, as it ensures that the sensor can provide accurate readings, especially during cold starts. If the heater circuit malfunctions, it can cause the oxygen sensor to operate below optimal temperature, leading to delayed responsiveness and degraded performance. Several issues can cause the presence of DTC P0135 in your Honda HRV. A failed AF sensor, sensor 1, is the most apparent reason, where the sensor's internal components no longer function as intended. Additionally, a blown fuse, specifically the B30 fuse, can interrupt the power supply to the sensor's heater circuit, causing a malfunction. Existing short or open circuits along the wiring can also lead to communication failures between the sensor and the powertrain control module, PCM. Another potential culprit is connector issues, where corrosion or loose connections might inhibit proper electrical flow. Finally, if the PCM software is outdated, it may not effectively manage the sensor readings, necessitating an update or replacement of the module to ensure compatibility and optimal performance. When the DTC P0135 is triggered, several symptoms may manifest in your Honda HRV. The most immediate indication is the illumination of the check engine light, alerting you to an issue with the vehicle. You may also observe poor fuel economy as the engine struggles to maintain an optimal air-fuel mixture due to faulty sensor readings. Increased emissions can occur as a result of improper combustion, which not only affects vehicle performance, but can lead to potential compliance issues with environmental regulations. Drivers may notice rough idling, where the engine fails to operate smoothly, causing vibrations or unusual noises. Lastly, a general decrease in performance may be evident, with the vehicle lacking responsiveness during acceleration due to inefficient engine operation. Recognizing these symptoms quickly can help mitigate further issues. The first step in troubleshooting DTC P0135 involves verifying the issue using the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode without starting the engine. Once the vehicle is in this mode, utilize the HDS to clear the DTC. Following this, start the engine and hold the RPM at 3000 without load, which means placing the continuously variable transmission, CVT, in park or neutral, or the manual transmission, MT, in neutral. This elevated RPM serves to activate various engine components and sensors, including the heater circuit of the A-factor sensor. After holding this speed until the radiator fan engages, let the engine idle and subsequently check for any pending or confirmed DTCs using the HDS. This step helps determine if the failure is consistent or intermittent, guiding further diagnostics. For the second troubleshooting step, turn the vehicle off to ensure safety while inspecting the electrical components. Next, locate and check fuse number B30, which is a 7.5 ampere fuse located in the underhood fuse relay box. This fuse is critical as it supplies power to the A/F sensor's heater circuit. If the fuse is intact, you can proceed to the next step in the diagnosis. However, if the fuse is blown, it indicates a potential electrical fault in the circuit, which will necessitate a deeper investigation into wiring and connections. Ensuring you have a proper understanding of fuse functionality is essential, as a blown fuse can often point to a greater issue, such as short circuits or overcurrent conditions within the system. In the third step of troubleshooting DTC P0135, begin by disconnecting the 4P connector of the AF sensor, sensor 1. This disconnection is crucial as it isolates the sensor for accurate resistance measurement. With the sensor disconnected, you will measure the resistance across given test points 1 and 2, ensuring the vehicle is in the off/lock mode. The expected resistance should be within the range of 2.0 to 2.7 ohms at room temperature. This measurement is essential because it reflects the condition of the internal heater within the sensor. If the resistance falls outside this range, it suggests a malfunctioning sensor, necessitating its replacement. Understanding the significance of these measurements can help in quickly pinpointing sensor-related issues. The fourth step entails checking the internal circuit of the AF sensor, sensor 1. After ensuring the vehicle is in the off/lock mode and the sensor connector is still disconnected, perform a continuity test between test points and the AF sensor connector number 1. Specifically, you will check for continuity between the sensor's test points number 3 and number 4 appropriately. This test is important because it assesses whether there is a proper flow of electricity within the sensor's internal circuitry. If there is continuity, it indicates the internal circuit of the sensor is intact. But if not, the sensor must be replaced, as it may no longer provide accurate readings necessary for the vehicle's performance. Continuous operation of an impaired sensor can lead to further complications affecting vehicle efficiency. In the fifth troubleshooting step, the focus shifts to checking for short circuits in the AFHT, air-fuel heater signal line. Start by jumping the SCS, which stands for Service Check Signal Line, using the HDS to ensure the diagnostic system can continuously evaluate the circuits. Following this operation, disconnect the PCM, Powertrain Control Module Connector B, comprising 51 pins. From there, check for continuity between test points 1 and 2, the latter being connected to the body ground. This continuity test determines if the AFHT line is intact. If continuity is present, it shows the wiring is correctly connected without any shorts. In contrast, if there is continuity, it indicates a short between the AF sensor and the PCM, necessitating repairs in the AFHT wire to prevent further complications in the heater circuit. For the sixth step, you will again check the AFHT line, but this time for any open circuits. With the vehicle in the off mode and both the AF sensor and PCM connectors still disconnected, check for continuity between test points number 4 of the AF sensor and number 19 of the PCM. This step is essential, as it will reveal if there are any breaks in the circuit. Detecting lack of continuity indicates there is an open in the AFHT wire that needs to be repaired to ensure the heater circuit operates as intended. Without a complete circuit, the AF sensor will fail to function correctly, leading to the potential triggering of DTC P0135. Proper understanding of the procedure and continuity testing makes for a more effective troubleshooting process, quickly targeting the underlying issue. In the 7th troubleshooting step, the goal is to assess the IGPS LAF Plus fill outline for voltage. Start by turning the vehicle into the on mode, ensuring the ignition is active but the engine is off. With the AF sensor, sensor 1, and PCM connectors still disconnected, measure the voltage between test points number 3 of the sensor and body ground. The presence of battery voltage at this point affirms the wire responsible for sending the signal to the AF sensor is operational. If you confirm voltage levels, the wiring is intact. And if there are issues detected, the wiring needs to be examined for potential opens. If issues persist even after wiring verification, it may indicate a need to update the PCM software or possibly substitute a known good PCM to resolve the DTC P0135. The final troubleshooting step focuses on ensuring the integrity of the IGPS LAF Plus FI sub RLY outline. Begin by verifying continuity between test points number 3 of the AF sensor and body ground, again while the vehicle is in the off mode. This continuity assessment will reveal whether any shorts exist within the IGPS wire. If continuity is present, the wire itself is functional. However, if not, it's a clear indication there might be a short or disconnection somewhere between the sensor connection and the number B30 fuse in the underhood fuse relay box. Ensuring proper communication in this wiring is critical, as any issues can lead to sensor failure and the resulting DTC. If necessary, repairs to the wiring must be implemented to restore circuit functionality and eliminate the P0135 code. After completing the troubleshooting and any necessary repairs concerning DTC P0135, it is vital to verify that all repairs were effective. Start by using the Honda Diagnostics System, HDS, to clear the DTC, effectively resetting any alerts. Following this, perform a test drive of the vehicle to observe how it operates under various conditions. During the drive, keep an eye on certain performance metrics. Specifically, monitor engine performance for signs of improvement, such as smoother idling and acceleration. After the test drive, reconnect the HDS to check for any recurring issues. If DTC P0135 reappears, it indicates that further diagnosis is required. Ensuring these steps are thoroughly executed helps confirm that the issue has been addressed effectively, maintaining vehicle reliability. To avoid future occurrences of DTC P0135 and maintain the integrity of the AFAT sensor, Sensor 1, implementing preventive maintenance is crucial. Begin with regular checks of the sensor's performance and functionality, ensuring it is operating within specified parameters. This includes regularly inspecting wiring connections for signs of wear and corrosion, which can negatively impact the sensor's performance. Keeping the vehicle's PCM software updated is equally important, as advancements in software can enhance the management of sensor inputs. Scheduling routine vehicle diagnostics can also help catch emerging issues before they escalate into more significant problems. Emphasizing preventive measures creates a proactive strategy to maintain optimal vehicle performance and longevity. To summarize, DTC P0135 signifies a malfunction in the A/F sensor, Sensor 1, heater circuit, which can significantly affect engine performance and emissions. A systematic approach to troubleshooting should include verifying the sensor condition, checking relevant fuses, and ensuring wiring integrity. Assessing both the internal circuitry of the sensor and external connections will help pinpoint the specific issue more accurately. Keeping the PCM software up to date ensures that the system operates smoothly, adapting to any changes in sensor capabilities. By adhering to a routine checkup schedule and employing preventive maintenance strategies, vehicle owners can help mitigate the occurrences of such DTCs in the future, leading to a more stable and efficient automotive experience. Please like and subscribe to the channel. See you next time.